Script is done 887 words, within the 5% band of the 900-word target. Hitting the required flow. Cold hook with the filled-in hook template. Stakes setup. First revelation, the Atlantic-Pacific pattern interrupt. Deep revelation with the Tohoku/1918 tsunami stakes escalation. The inner ear callback in the implications section. And an unresolved cliffhanger with a fresh question at the end. The trench that's still rising. Scientists can't stop its shorts. The pressure-sensing reason your inner ear hides the ocean's slow rise from you. And in 2018, off the coast of Puerto Rico, it exposed a trench floor that should be sinking, not climbing. Right now, 7 miles beneath the surface, the seafloor is pushing upward instead of down. Your body was engineered to never register that shift. That silence is the whole problem. Every trench on Earth is supposed to work like a one-way door. Plates dive down, get swallowed, disappear into the mantle forever. That's the deal your entire coastline has quietly run on for millions of years. But the Puerto Rico Trench, the deepest point in the whole Atlantic Ocean, stopped following that rule. Sensors anchored to its floor started recording something researchers weren't prepared for. The seabed wasn't dropping like the textbooks promised. It was rising, slowly, steadily, like something underneath refused to stay buried any longer. And this particular trench sits less than 500 miles from Miami, close enough that somewhere else stops being an option. In 2018, a research team lowered pressure gauges into the Milwaukee Deep, the trench's lowest point, 8,376 meters down, deeper than 28 Empire State Buildings stacked end to end. They expected the normal signature of a subducting plate, gradual sinking, as one slab slides beneath another the way it's supposed to. Instead, over months of readings, the seafloor measurably lifted. Only centimeters, but centimeters that shouldn't exist in a system built entirely on downward motion. The cause traced back to something called plate locking, two tectonic slabs jammed against each other, unable to slide, storing every inch of blocked movement as raw, compressed strain instead of releasing it. The trench wasn't broken. It was loading quietly, like a spring being wound tighter with nobody watching the mechanism. And nobody could say how long it had already been holding that tension, because the instruments that finally caught it had only existed for a few months. Here's the part that flips everything you just assumed. Scientists figured locked, rising trenches like this belonged only to the Pacific's most violent subduction zones, Japan, Chile, Sumatra, places already famous for megaquakes. The Atlantic was supposed to be the calm ocean. Boring, passive. A place where plates glide instead of grind against each other. That assumption just failed a live test, in real time with real instruments. If a trench in the quiet ocean can lock and rise undetected for who knows how long, every trench you've never even heard of could be doing the exact same thing right now. Invisible, unmeasured, unmonitored, simply because nobody thought to look there first. Locking means the plates aren't sliding past each other in small, harmless increments anymore. They're frozen together, and the entire built-up motion of years, maybe decades, gets stored as elastic strain inside solid rock, exactly like a bow bent back and never allowed to release its arrow. Eventually, locked sections fail. When they do, they don't creep. They snap. That sudden release is what generates a megathrust earthquake, and when the seafloor itself lurches vertically in that failure, it doesn't just shake, it shoves an entire column of ocean water upward above it. That displaced water is a tsunami. The 2011 Tohoku earthquake in Japan came from precisely this mechanism. A locked trench segment finally slipping after building strain for generations, hurling a wall of water into a coastline with some of the most advanced warning systems on the planet, and still killing over 18,000 people. The Puerto Rico Trench sits at the edge of the Caribbean plate, within direct striking distance of Puerto Rico, the Dominican Republic, and the southeastern United States seaboard. Researchers have already linked this exact fault system to a documented 1918 tsunami that killed dozens along Puerto Rico's coast, decades before anyone had instruments sensitive enough to see the strain building underneath it. The rise scientists caught in 2018 isn't a new phenomenon. It's the same mechanism, finally getting witnessed instead of discovered after the fact. So why did it take until 2018 to even notice a rise this significant? Because the ocean floor doesn't send you a warning. Your inner ear, the organ that tells your brain up from down, pressure from calm, was never built to sense stress accumulating 7 miles beneath a boat. Neither were the ships crossing that water every single day, oblivious to the slab locking tighter beneath their hulls with every passing month. The only reason anyone knows about this now is because someone finally dropped instruments into a place everyone assumed had already finished changing millions of years ago. Which raises the uncomfortable question underneath all of this. How many other trenches right now are rising in total silence, simply because nobody has dropped a sensor down far enough to catch them yet? Scientists still can't say when this stored strain releases, or how large the eventual rupture will be. They only know locked sections never stay locked forever. Somewhere beneath that rising floor, 7 miles down, off a coastline you've probably flown over, the clock is already running. And the real question isn't whether it goes off. It's whether the next trench quietly doing the same thing has already been found, or is still sitting there, unwatched, right now.